Some time ago, we purchased a beautiful 1958 Chris Craft boat from the original owner. It was a 17-foot deluxe runabout that originated in northern New York State. In 1985, the original owners retired to San Diego and had plans to completely restore it. Due to health issues, they were forced to put it up for sale. I'm very proud to become the second owner and truly respect the history that came with it. The following is a two-part story. We did a complete restoration of the boat, including interior, engine and drive overhaul, hull plank removal, plywood installation including exterior varnish and hull paint. After completing the restoration, we had many hours of great fun on various lakes in Arizona. There was always a great concern, however, because there was never enough time in the water to have the planks swell enough to prevent significant leakage. On a couple of occasions, while the boat was in the water for 24 hours and overnight, the bilge pump came on and drained a significant amount of water. Needless to say, I did not sleep well that night. You see, the boat is garage kept in Phoenix, Arizona, where the summer temperature can reach 115 degrees and the humidity averages around 10%. Thus, always a very dry hull. This weighed on my mind for a long time. After a great deal of research, I decided to undertake the application of fiberglass to the existing hull. I am very confident that the process I developed will result in many, many years of boating pleasure with very little fear of degradation to the boat. The detailed process of fiberglassing the hull is explained by the following video still narrative presentation, which contains a basic step-by-step procedure for preparing and applying a fiberglass hull to a wooden boat. For optimum working access and convenience, the entire interior contents of the boat were removed and the boat was flipped over with substantial bracing and support. Flipping the boat was quite a challenge in itself. Part 1. The following first set of photos show the results of sanding the entire exterior, including the careful removal of the original hull planks and marine plywood. Special attention and care was used when removing the planks to ensure they could be reattached after new plywood was installed. The old plywood was used as a template to make a perfect fit replacement with new heavy-duty quarter-inch marine plywood. All seams of the plywood had 3M 5200 applied and multiple coats of Petite 2018 clear sealer was generously applied to the plywood prior to reattaching the mahogany planks. All mahogany planks were reattached using brass screws in the existing holes. Most screws were reused. Where needed, new holes were drilled and properly countersunk. Naturally, after fastening the planks, new bung plugs had to be glued and set. When everything was dry, plugs were sheared and power sanded to the surface with a 400 grit, and it was done to improve the bonding for the upcoming 3M 5200. Part 2. This section defines the merging edge between the hull section on the waterline and establishes a perfect method for bonding the fiberglass to prevent any moisture egress. In these photos you can see that I have planed the hull surface on the side approximately 3/16 of an inch and nearly all the way down to the waterline mark. I left about 1/8 of an inch of the original waterline to ensure placement of the seam is correct. Next, I purchased a roll of high-quality double-back tape and a 40-foot by 1/4 inch by 1 1/4 inch plastic trim. This plastic trim is extremely flexible and will be fastened with the double-back tape at the edge of the waterline edge. This is used to define the maximum thickness of the material of the 5200 C-Flex, CSM, and vinyl ester, which will be applied to the hull up to the waterline. In addition, a plastic sheet is attached to this trim for added protection to the boat. Prior to application of the 3M 5200 and fiberglass, I installed two 3/8 inch threaded rods as a temporary position for later installation of the rudder stuffing box fixture. Also, I filled the existing 4 strut mounting holes with 3M 5200 because it will be repositioned after the added thickness of the hull is achieved. The strut will also need to have a small portion cut off to make clearance for attaching the propeller. This will be discussed and shown later. C-Flex is a type of fiberglass that was created by Seaman Composite Incorporated. It's made up by using continuous, flattened, longitudinal glass rods with roving in between, and it's all woven together with a light fiberglass cloth to keep things in position. This allows it to be worked on the bias to create compound surfaces. The small rods, spaced approximately 1/2 inch on centers, are protruded like some fishing rods, so that makes them a far denser and stronger product than normal glass roving and resin. C-Flex is sold in rolls up to 250 feet in length and comes in just 2 sizes or weights, both being 12 inches wide. The rods I chose are 0.08 inches in diameter, or the C39 version. I purchased the C-Flex C39 and 3M 5200 from Sea Chest Marine of New Orleans, Louisiana. In my application, I elected to lay the C39 perpendicular rather than lengthwise. Since the planks are remaining, my glass application will give the hull significant additional lateral strength. I cut each piece of the C39 as shown by using a metal hand shear. This is a difficult task because all the rods require cutting. After all were cut and laid out, I numbered each and made a paper template for later reference. Applying the C-Flex C39 was quite simple since the 3M 5200 stays wet for quite a long time, giving you plenty of time to attach the C-Flex material. For my 17-foot boat, 5 gallons of 3M 5200 was needed. Approximately 1/2 gallon was left over. I applied the 5200 with a 1/4 inch notch trawl. On the wet surface of the 3M 5200, I began stapling the C-Flex. It is important to use only stainless steel staples. Using a power stapler, I selected 3/8 inch staples and stapled every 4 inches vertically and horizontally. After all the material was stapled, I used a lightweight hammer to tap each staple to ensure uniform fastening. This section of photos does not provide a great deal of detail. I did not capture a photo of the first layer of the woven roving. At this stage, I was very focused on the job at hand and not photo documenting the steps. I'll use a narrative for each photo as a method to provide detail. After the 3M 5200 had ample time to dry, in my case I waited over a week, the process of applying the resin and the various layers of glass will occur in a continuous process. Make sure you plan the process early and have a couple of extra hands to manage the large section of glass material. I applied 3 individual layers of glass, an 18-ounce woven roving as first layer and 2 layers of 1.5-ounce CSM. I pre-cut each piece with approximately 8 inches of overlap at the keel and a few inches along the sides. I used a foam roller applicator to apply the resin to each layer. Make sure that no bubbles develop. As the resin begins to set, you can use a metal roller to help move any of the trapped air out. This process goes pretty fast. Once you have the first layer down with no bubbles, you can begin to apply the second. As long as the resin is tacky to the touch, you can begin applying the next layer. After the fiberglass is hardened, I began preparing the surface for the vinyl ester primer. I used a 400 grit paper on a belt sander to knock off all the high spots and give the surface a good coarse texture for the primer to adhere. Where the propeller shaft protrudes through the hull, I added 6 number 8 brass countersunk screws to ensure a tight, continuous bond of the glass layers to the wooden hull and to prevent future separation. After the fiberglass surface has been sanded and cleaned of any foreign material, it was time to apply the vinyl ester primer. This primer was provided by SureFab Unlimited Inc. of Ontario, California. It was recommended to apply the primer with a sprayer, but after doing a few tests, I discovered a roller was the best. The primer uses a hardener, so make sure you have 4 or 5 new rollers standing by because it cures within 10 to 15 minutes. And to apply a multiple coats, you need a new roller each time. And always follow manufacturer's safety instructions. After the primer hardened, I used my belt sander to level and get the surface prepared for the paint. At the same time, I was able to shape the bonding edge in preparation for attaching the waterline edge seal. The waterline edge seal is made of a 0.75 by 1.25 mahogany strip. Since the new glass hull surface was not flush with the mahogany side, I had to notch the edge with my router. In my application, I notched the edge 3/16 of an inch deep by 1/2 inch wide. The edge will be fastened every 6 inches with a number 8 brass countersunk screw and capped with a mahogany bung plug. The edge was attached temporarily to properly define where each screw should be placed and to ensure proper fit and form. The entire edge was removed and the 3M 5200 applied at the joint of the fiberglass and mahogany sides. Then it was reattached permanently. After installation of the edge and drying of the bung plugs, I shared each plug and sanded the surface carefully. The next step was to apply the Petite 1959 copper bronze bottom paint to the vinyl ester primer and Bootstripe Boot W paint to the waterline edge. These were purchased from Classic Boat Connection of Mankato, Minnesota. After a couple of days for adequate drying, I attached the bottom drain fitting, coolant water inlet scoop, water siphon exit fitting, and propeller shaft strut. Drilling was done with a hole saw from inside the hull. For each, I applied 3M 5200 as a gasket. The strut will have a slightly new position due to the added thickness of the material in the hull. I temporarily installed the propeller shaft and stuffing box shaft log to establish the exact location of the strut before drilling the new 4 mounting holes. When it comes time to finally install the propeller, you'll need to cut approximately a 1/2 inch off the aft end of the strut so the propeller can be properly secured. In my application, there was plenty of strut material to work with. I sincerely hope this brief tutorial was helpful to you. It was not intended to convince anyone to do what I did, only to explain why I felt it was necessary for me and to document the steps I took to fiberglass my hull. Thank you.